Hello everyone, I hope everyone is doing fine at home. In view of the present crisis, I've decided to have some videos sent to you all, and this chapter bearing capacity from Unit 2 will be covering through this video lecture series. Today's will be a 15 minutes video wherein we are only going to cover the basic terms and definitions in this chapter bearing capacity. Okay, so we all have heard of this word bearing capacity, but what it is, that will be dealing in details in this chapter. Okay, in a simple language, if you want to find out what is bearing capacity, it is the supporting power of the soil or a rock on which your structure is going to come. So what happens if the bearing capacity is good? You need not go for a massive foundation. So what is the reason we have this foundation? We have various functions of foundation. Primary function of the foundation will be to distribute the load coming from the superstructure onto the soil underneath, right? So when you are going to design any foundation, it's going to be designed for two primary aspects. First one is it should not fail in shear, okay, and it should be able to resist all the types of settlement. So we are going to define various terms today. They will be mainly in terms of the shear failure or settlement failure. Alright. Now the first definition that we are going to do is ultimate bearing capacity. Now the suffixes or the terms that I have taken up from your textbook. Okay, we will follow the same way of depicting this terminology. Now QF will stand for ultimate bearing capacity. Okay. Now everywhere I have made, if a term is defined in terms of shear failure, I have seen to it that I have made this red. So any definition when I am saying ultimate bearing capacity or net bearing capacity, you should understand this I am defining in terms of shear failure. There will be some terms which I am going to define in terms of settlement failure. Okay. So now ultimate bearing capacity is the gross pressure intensity at the base of foundation wherein the soil will fail in shear. Okay, so what is ultimate bearing capacity? It is the gross pressure intensity at base of foundation. So when I say ultimate bearing capacity of soil is so and so, okay, first question we need to ask ourselves is where are we finding the ultimate bearing capacity? At what point? Everywhere in the soil that the value will not remain same. So we are trying to find out ultimate bearing capacity at the base of the foundation. So if our foundation is being laid at, let's say, 1.5 meters, then I need to find out what is the ultimate bearing capacity at 1.5 meters, and that value will be for a gross pressure intensity. Now what do you mean by gross pressure intensity? See, when you are going to construct any structure at, let's say now in this case, at 1.5 meter, when I am constructing a building, say for example, there will be stress due to weight of the foundation, there will be stress due to weight of the superstructure, and what are the other things? Let's say that if there is any filling that is going to be done while I construct the building, that is also going to contribute to some weight, right? So at 1.5 meter, the pressure that the soil will be facing will be because of primarily three aspects: foundation weight, weight of the superstructure, and weight of the filling. So all these three together will be contributing to gross pressure intensity. And what is ultimate bearing capacity? It is the minimum gross pressure intensity at which the soil will fail. Okay. So what are the keywords? First one is gross pressure intensity, and this will be what will be the minimum gross pressure intensity at which the soil will fail at the base, that is called the ultimate bearing capacity. Are you understanding? So at 1.5 meters, what will be the pressure due to foundation weight, due to superstructure, and due to filling, which will cause shear in the soil? That will be ultimate bearing capacity. Alright. Now the next term will be net ultimate bearing capacity. So when I say net, that means there will be something which will be deducted. Now coming back to our example, let's say I have a plot and I need to find out at 1.5 meter what is the net ultimate bearing capacity. Now why do I have this net ultimate bearing capacity? See, even before I construct something at 1.5 meter, will there be some pressure? Yes, there will be. Why? Although there is no foundation, there is no structure coming up, but still at 1.5 meter, that soil will be under some pressure. Why? Because of its own overburden. Okay. So what will be by df? 1.5 meter, gamma will be the unit weight of that soil. So at 1.5 meter, even before I start constructing, this much pressure will be anyway existing. Gamma into df. After I construct, those three factors come into play. Which are the three factors? The weight of the foundation, weight of the superstructure, and the filling, which are going to constitute this particular term. The difference between the two terms is going to give me net ultimate bearing capacity. So it is a net increase in the pressure at the base of foundation that will cause shear failure in the soil. Again, this is also the minimum pressure at which shear will occur in the soil. Alright. The next term is net safe bearing capacity. It's going to be denoted as QNS. Now over here while typing I have typed everything together. However, these terms N, S and all, they are supposed to be suffixes. Okay. So net safe bearing capacity, it is the net soil pressure which can be safely applied to the soil considering only shear failure. Okay. So we are not considering so far nowhere the settlement has come into picture. So it is the net soil pressure which can be safely applied. So the key word is safely applied. So what we do, we kind of factor it. We try to design it little safe. Okay. So we apply a factor of safety to net bearing capacity. Now this factor of safety will range from 2 to 4. Now when do we take it as 2? When do we take it as 4? There are various factors that will decide this value. Let's say the method of exploration that we have adopted, the type of the soil, let's say soil is very much stratified and it's changing its profile very quickly. The method of exploration, we have not gone very deep to find out, okay, or if there is any other type of uncertainty, let's say we don't know about the moisture content of the soil or the importance of the structure. See, if I am constructing a normal G+2 building, if there is sufficient amount of data, soil explorations are done very well, data collected is also very extensive, then I may go for just 2. But in the same building, if the data collection is not done extensively, I have taken just let's say 1 or 2 bore logs, okay, then I will go for let's say I will go for 3 as a factor of safety. In place of building, if I am constructing dam, okay, then I will start only with 3. Considering that there is a exhaustive data available, I will go for let's say I will start with 3. But if I have any doubt in my mind that whatever are the bore logs taken may not be appropriately taken, or the bore log data is insufficient, or the method of exploration was not properly done, then I will go for even 4. Okay, so these are various factors that influence this factor of safety. The next term is gross safe bearing capacity. Now this is also called SBC. All from our third semester, all this while we have been hearing this SBC. What is SBC? Technically it is called gross safe bearing capacity. Now what is gross safe bearing capacity? It will be designated as Q suffix S and it will be written as QS is equal to QNS plus overburden. Okay, it's the net safe bearing capacity plus the overburden. Now net safe bearing capacity is given as QNF divided by F, so I have directly substituted. Again, SBC is the maximum pressure which the soil can carry. Now this is the first time we are coming across the word maximum. Okay, it's the maximum pressure that the soil can carry safely without shear failure. Okay, now the next slide we are going to start talking about the safety in terms of settlement. So the next term is net safe settlement pressure. It is the net pressure which the soil can carry without exceeding allowable settlement. See, every structure, let's say for example you have a building, it has a permissible amount of settlements which are already written down in our codes. Okay, so let's say the permissible settlement for your structure is around 5 centimeter. So how much is the pressure that this soil can be subjected to, wherein the settlements will be not exceeding 5 centimeter. Okay, so that is called the net settlement, safe settlement pressure, QNP. N and P are in suffix. So that is basically for a specified amount of settlement, or for a specified permissible settlement, how much is the intensity of loading that we can go up to. That is the net safe settlement pressure. Net allowable bearing pressure, which will be written as QA, it is the net bearing pressure which the soil can be used for design of foundation. Now, QA value will be minimum of this net safe settlement and SBC. So, if say SBC value you are getting as around, let's say 15 kilonewton per meter square, and net safe settlement pressure you are getting it as 10. From the settlement point of view, you are getting a lesser value, and from the shear point of view, let's say you are getting a higher value of 15. You will be designing it for the lower value. So that is what is written in these equations. So QA, that is allowable bearing pressure, will be QNS, that is SBC, if this NS is lesser than NP. Are you understanding? Whichever is the lesser value, you are going to be designing your structure for that particular value, so that your structure is safe. So with this, we come to the end of technical definitions. Please see that you understand this very clearly, because henceforth in the next lectures I am directly going to use the terms without giving you all the explanations. Alright, thank you. Study well, stay safe.